So now we will discuss exponents and logarithms in the Numpy. We will discuss this, and now let's start with the codes. So another common type of operation available in Numpy UFunk are the exponentials. For example, here we can write x is equals to in the square bracket 1, 2, 3. Print x double quotes x 1, 2, 3, 4, 5. Print e raised to power x, e raised to power x, and p dot print 2 raised to power x 1, 2, 3, 4, 5, and p dot exp. Print 3 So here is the answer. So the inverse of the exponentials, the logarithms, are also available. The basic np.log gives the natural logarithm. If you prefer to compute the base 2 logarithm or the base 10 logarithm, these are available as well. Starting off with x is equals to 1, 2, 4, 10. Print x 1, 2, 3, 4, 5, 6. Print ln 1, 2, 3, 4, 5, 6. We go to 5. Let's copy that down. Just changing log to x. 2. Log 10x. Log 10. So this results in this. So there are also there are some specialized versions that are useful for maintaining precision with very small output. X is equals to 0, 0, 0 0.001, 0 0.01, 0.1. Print xp minus 1 p dot exmp 1. Print log 1 plus x np dot log 1p. We have an error. 2. Let's look at the error. Module Numpy has no attribute. xpm. This gives the answer, this one. So when x is very small, these functions give more precise values than if the raw np.log or np.exp were used. So now we will discuss specialized ufuncs. So NumPy has many more ufuncs available, including hyperbolic trigonometric functions, bitwise arithmetic comparison operators, conversions from radians to degrees, rounding and remainders, and much more. A look through the NumPy documentation reveals a lot of interesting functionality. Another excellent source for more specialized and obscure ufuncs is the submodule scipy.special. If you want to compute some obscure mathematical function on your data, chances are it is implemented in scipy.special. There are far too many functions to list them all, but now the snippet I'm going to show you, that a couple of that might come up in a statistics context. Starting out from scipy, import special. Now gamma functions, generalized factorials, and related functions are gonna run here. This is the comment, x is equals to 1, 5, 10 in the square bracket. Gamma equals to special dot gamma. I will copy that down. I will change ln. Gamma ln. Now we will do that. Okay, we will now put ln natural log. Replace this with beta 2 we have an error here. Now let's see the error. Print beta 2. We have to answer this. So now we will write another code with error function, integral of Gaussian, its complement, and its inverse. X is equals to np dot array 0, 0 0.3, 0 0.7, and 1. 1, 3. Print erf 2, 3, 4 special dot erf copy that down. ERFC, now we will put C here. Now we will put ERF, INV, inverse. We will enter, we will get the result this, ERF x is equals to this, and ERFC is equals to this, and ERF INV inverse is equals to x is equals to this. So there are many more ufuncs available in both NumPy and SciPy.special. Because of the documentation of these packages is available online, a web search along the lines of gamma function Python will generally find the relevant information.